Now we are discussing about a signal generating device. We already discussed about the CRO. On the CRO we can only observe the signal, but CRO itself cannot generate the signal. We can observe the electric signal on the CRO, and we discussed simultaneously we can observe two signals on this CRO. That's why it is called as dual channel CRO. Some CROs may use 4 channels. That is called as quadra channel CRO. So it is not generating any signal. We are taking a signal generating device. This function generator is a signal generating the device. As the name is there, generator. It is generating the signal. But why we are saying function generator? Because whatever the signals we are taking, sinusoidal signals, square signal or triangular signals, all these can be represented as your mathematical functions. That's why it is called as function generator. This function generator is used to generate the signal. Basically, we have 3 types of signals here, either square wave or sinusoidal wave or triangular wave. These 3 signals, voltage signals, can be generated on this function generator, but we cannot observe the signals on the function generator. Even though the function generator is generating the signal, but we do not know how the signal is. In order to know how the signal is, we connect this signal to the CRO. When we connect this signal to the CRO, then we can observe how the signal in the reality is. In your second year and third year experiments, and also in first year if required in some experiments, you can observe the signal on the CRO. Whenever we want to see the output signal, how the signal is, we use the CRO only. In the CRO only we observe the signal and we will take the readings. So here we are trying to connect one basic signal by using the function generator. This is 1 MHz function generator, means maximum frequency signal we can generate is 1 MHz. From 1 Hz to 1 MHz signals we can generate by using this function generator. Now I am turning on the function generator. Supply is on. Here the signal frequency is 864, 870. I am using this knob. This knob I am changing to change the frequency. We already discussed in the theory. By using the capacitor, variable capacitances, we can change the frequency. So here we are using a potentiometer to change the frequency. We are changing the frequency simply by using one knob. Similarly, there is one more knob to control the amplitude. We already discussed in our theory, in order to control the voltage, we use the wire-wound potentiometers, whereas for the volume control, we use the carbon potentiometers. Here we can control the amplitude of the signal and frequency of the signal. I am taking a 1 kHz signal. The signal frequency is 1 kHz. Roughly it is 1.06, but that is fine because I am trying to, okay, now I got some 1.01. So the signal frequency is 1.01, almost it is 1 kHz signal. But as we discussed already, if the signal I am directly giving through the wire, it might be attenuated. So I am connecting by using the same CRO probe, which is BNC connector I am using. So here the signal is there now, but we cannot observe with our physical eyes. In order to see the signal, we have to connect this signal to the CRO. Now I am taking one more BNC connector and a CRO probe. So here, now we are taking the signal from the function generator by using the CRO probe. We have connected the bayonet connector, and these 2 pins are called as crocodile pins. These pins, they are appearing like the mouth of the crocodile, that's why it is called as crocodile pin. Here the signal is there, but very small signal. That's why only even if I am touching, I am not getting shock, but if it is a very high voltage signal, then definitely I will get the shock. Now, this signal I want to see on the CRO. In order to see on the CRO, because I cannot see with my physical eyes, the signal is there. Now, at this 2 crocodile pinch, the signal is there, but we cannot see. In order to see the signal, we have to use the CRO. Again, I am taking one more BNC connector, one more CRO probe I am taking. I am connecting the CRO probe to the channel 1. We have 2 channels. I am connecting it to channel 1. Now, negative terminal I am connecting to the Now I am connecting the negative terminal to the negative. And I am connecting the positive terminal to the positive. Now you see, we are observing a sinusoidal signal on the CRO. This sinusoidal signal frequency is 1 kHz. The signal frequency is 1 kHz and the peak to peak amplitude is 2.08 volts. As I mentioned already, the signal amplitude can be controlled by using the function generator. See, I am reducing the signal amplitude. And similarly, signal frequency is controlled by using the function generator. If I want to change the signal, those changes can be made on the function generator only. On the CRO only I can see the signal. But if I want to make any changes, those changes can be made on the function generator. In this CRO, we are observing the sinusoidal signal. I want to make it large, amplitude, so you see here, but the signal amplitude is not changing. We are scaling the signal. Even though the signal appearing as more than the previous one, but signal can be changed only by using the function generator. On the CRO only, whenever I am modifying the signal, that is only for my convenience. Signal change can be done only on the function generator because the signal generation is the function generator part. Only we can observe the signal on the CRO. Whatever knobs we are using on the CRO, either to reduce, but the signal amplitude is not at all reducing. Only it is for our convenience. Even though I am changing the signal for my convenience, the voltage is same. Example, now the voltage I am giving from the function generator is 1.75. If I am decreasing also, voltage is 1.75. Even if I am increasing also, voltage is 1.75. Okay, almost roughly 1.79 the signal voltage we are getting. That's fine. Now I want to see the square wave. Then you give the square, you observe the square wave signal. Similarly, triangular wave can be observed on this. So these 3 basic signals, triangular wave, sinusoidal and square waves, can be observed on the CRO by using the function generator. These are the 3 basic signals we are generating from the function generator. This signal can be moved along the y-axis by using this knob. See, I am moving the signal. Clockwise means it is going up, anti-clockwise means it is going down. Y-axis can be controlled by using this knob. See, clockwise means it is increasing, anti-clockwise means it is decreasing. Similarly, x-axis of the signal can be controlled by using this knob. Clockwise means it is appearing like the signal is enlarging, anti-clockwise means it is appearing like the signal is compressing. And along with this, some more functions are there in the digital CRO. But as per now, as you are in present first year, these functions are sufficient for you to understand the CRO. Okay. Finally, we are discussing that on the CRO we can see the electric signal. But who will generate the who generates the electric signal? Function generator. This signal can be displayed on the CRO. Function generator generates the signal. This can be displayed on the CRO.